Hi everyone, my name is Bang Đăng Phạm, and on behalf of our team VNI Research Vietnam, today I will introduce you our work HyperCUT video sequence from a single blurry image using unsupervised ordering. Image to video deblurring or blur to video aims to recover a sequence of sharp images corresponding to a given blurry image. However, both the forward and backward sequences are plausible solutions. It creates a big issue for this task called order ambiguity, lead to failure in training, and generate the incorrect motion. In this paper, we propose an effective self-supervised ordering scheme called HyperCUT that assigns an explicit order for each video sequence and embed it as a regularization when training the deblurring network to avoid the order ambiguity. In addition, we provide the first real-world blur-to-video dataset that covers a variety of popular domains, including face, hand, and street. As a result, our model outperforms the state-of-the-art models in both synthetic and real-world benchmarks. First and foremost, we will introduce the motivation for the blur-to-video task. In the slide, this is an example of image deblurring. As you can see in the blurry region, this stat only tries to improve the aesthetic look. So what about this one? You can see the whole dynamic process. It would be more efficient to analyze the dynamic motion which creates the blur in the real life. Moreover, it would provide you a sequential context of motion and have to review more information than a single static image through scenarios. Now, we go through some previous works. The first one is the naive optimization approach. This work only optimized for each frame independently. It would easily suffer from order ambiguity. For better comprehension, we will illustrate it through the toys example. As you can see in the slide, the deblurring model almost converges to the average of all sample targets. Another loss function is proposed called order invariant loss, which computes the total loss on frames at symmetric index. However, this loss does not fully resolve the issue of having multiple failed solutions. Specifically, the object in the deblurring frame could be torn off, but it still satisfies the condition. Recently, another institution solved the order ambiguity issue by applying the additional input called motion guidance, which is generated by the condition variation autoencoder. This approach could solve the multi-directional blurry motion and have a better result from the refinement process. However, the motion largely depends on the quality of the motion guidance and consequently failed when the human annotated data was not available or the estimated optical flow was incorrect. And based on those weaknesses, we set our goal for the proposed method that have to separate the solution space, consistent and efficient order alignment, and no heuristic dependence. Let's start with the pair of symmetric index frame. The order ambiguity happens when this pair is not consistent between iterations. So in our method, we try to force them into a different side of a hyperplane by training a mapping function, and by this way, we can assign an explicit order for each scene throughout iterations, thus leading to a certainty of symmetric ordering between frames. So, for each sample, this is an objective of our HyperCUT mapping function. To optimize that one, we will minimize the dot product of two mapping functions of a symmetric index frame that we want to force them into different sides through hyperplane, and apply the soft loss function to limit the lower bound of this loss. To apply our proposed method to the deblurring network, we utilize the frozen HyperCUT model as a regularization in the training process. This regularization enforces all synthesized pairs to stay on the same negative side of the hyperplane, and it can be combined with other deblurring losses with alpha hyperparameter. That is all about our proposed method. Now, about the dataset. Another contribution of our paper is the first real-world blur-to-video dataset that we capture by our beam splitter camera system, which is built with the low and the high-speed camera and the mirror in between to ensure capture the same image. And this dataset covers popular domains such as street, face, and hand. Moreover, we also experience our model with two popular synthetic blurry datasets called BRAS and PAIST++. The next section is the quantitative and the qualitative result over benchmarks. First, we will introduce two new metrics that we can evaluate our HyperCUT accuracy, including hit ratio, which assesses the capability of our model to enforce the symmetric frame on different sides, and consistency ratio, which emphasizes whether the consecutive frame reside on the same side or not. As you can see in this table, our proposed self-supervised model can extract the ordering information effectively in all mentioned datasets. And we also use TSNE to visualize the representation vector. It can be observed that the map vectors are perfectly split into two clusters in both RAS and split datasets. About the deep learning network, we first introduce you a PM metric. Because the forward and the backward frames are valid solutions, we modify the standard quality metrics to accept both forward and backward order. The modified metrics have the prefix P, including PPSNR, PSSIM, and PLPIPS. As you can see in the table, our HyperCUT-based models provide a stable performance on all frames and consistently outperform the comparator models on all 6 border frames with 1 to 4 point gaps in the PPSNR scores. This is the qualitative result of two baseline methods compared to our HyperCUT-based model. Next, for a fair comparison, we reproduce the deep learning result with motion guidance paper and apply the HyperCUT with the same motion guidance input. And our model still outperforms the result from the original paper and the reproduced version. And this is the qualitative result. Summary: in this paper, we introduce HyperCUT, which is used to solve the order ambiguity issue effectively. We build a new dataset for blur-to-video task called RB2V. This is the first real and large-scale dataset for image-to-video deep learning. Our model achieves the state-of-the-art performance on both synthetic and real-world benchmarks. Future research on adapting the HyperCUT model for handling the complex movement and long exposure blur would be an interesting avenue for exploration. Thank you for your listening.